today our guest tutors, Ms. Charlene Col-long and Ms. Bonifacio, to help us out for today's topic, which is all about exponential functions.
So exponential function is a function whose value is a constant raised to a power of the argument, especially the function where the constant is e. Exponential function looks somewhat similar to functions you have seen before in that they involve exponents, but there is a big difference in that the variable is now the power rather than the base. Previously, you have dealt with functions as f of x equal to x squared, where the variable x was the base and the number 2 was the power. In the case of exponentials, however, you will be dealing with functions as f of x is equal to 2x, where the base is the fixed number and the power is the variable. The graph passes through the point 0, 1. The domain is all real numbers. The range is y greater than 0. The graph is increasing. The graph is asymptotic to the x-axis as x approaches negative infinity. The graph increases without bound as x approaches positive infinity. The graph is continuous. And lastly, the graph is smooth. To solve exponential equations without logarithms, you need to have equations with comparable exponential expressions on either side of the equal sign so you can compare the powers and solve. In other words, you have to have some base to some power equals the same base to some other power, where you set the two powers equal to each other and solve the resulting equation. For example,
since the bases 5 in each case are the same, then the only way the two expressions could be equal is for the powers also to be the same. That is, x is equal to 2. This solution demonstrates how this entire class of equation is solved.
if the bases are the same, then the powers must also be the same, in order for the two sides of the equation to be equal to each other. Since the powers must be the same, then you can set the two powers equal to each other and solve the resulting equation.
Since the bases are the same, one can equate the powers and solve 1 minus x is equal to 4. Transpose x to the right side of the equation and 4 to the left side of the equation. So you'll have 1 minus 4 is equal to x. So the value of x will become negative 3 is equal to x.
Sometimes, we'll first need to convert one side or the other, or even both, to some other base before you can set the powers equal to each other. For example,
since 9 is equal to 3 squared, this is really asking me to solve 3x is equal to 3 squared. By converting the 9 to a 3 squared, I've corrected the right-hand side of the equation to having the same base as the left-handed side. Since the bases are now the same, I can set the two powers equal to each other, which is x is equal to 2.
as you can probably tell, you will need to get good with your powers of numbers, such as the powers of 2 up to raised to 6 is equal to 64, the power of 3 up to raised to 5 is equal to 143, and the powers of 4 up to raised to 4 is equal to 256, and so on. Here are some examples to work with. With time and practice, you'll get it right. That's right, Dad.
Thank you so much for being here today, Science. We have learned a lot from you, haven't we? Afraid that's all the time that we have, guys.
Hope you've learned a lot from us today. Don't forget to subscribe, give us a thumbs up, and let us know in the comments down below if this video was helpful.
Follow us on Twitter